Hey everyone, let's go ahead and get started. Welcome to Code the Universe. My name is Sudan. I am a grad student here at Harvard, and I'll be teaching you this course throughout the next 2 weeks. So just for a high-level overview, what this course is, what you can expect from it, and what you can expect from today's lecture. This is, I think, one of 6 January term courses being taught here at Harvard for 2 weeks by grad students like myself. And in this course particularly, we're going to be exploring generative art, natural visualization, and mathematical visualization. We'll talk a little bit today about, who might be interested in this course, why you should take this course, the motivations behind generative art more broadly, and then we'll sort of get started with making our first couple of pieces. Okay, so I really hate slides, so we're going to try and get through as many slides as possible, as quickly as possible, and we'll keep them to a minimum more generally. I'll talk a little bit more about that in a couple of minutes. But first, I want to start with who this course is for. And I really wanted to spend a little bit of time talking about this because as of right now, I think we have like 105 different signups, which is really, really exciting. We have tons and tons of people that are here. And so I want to make sure that everybody knows what they can get out of this course because we have a very wide range of people with different backgrounds. So about 10.1% of you, that's going to be about 10. I think we have like 105 signups. So about 10 of you have never written a line of code before. Maybe you've never even seen a line of code before. And I'm really, really excited if you're in this camp. I think that this course will be a lot of fun visually if you've never written a line of code before. About 25.8% of you, 26% of you have written some code and you understand the basics of coding. So maybe you know how to print something out, you know how like if statements and for loops work, but maybe you don't know some of the more advanced data structures. You haven't done any big projects of your own yet. And that is totally cool. This is the camp that I was in when I first started generative art. So rest assured, this is totally going to be a course that is accessible if you are in this category. Now, 43.8% of you have done a few projects and you have a good grasp on at least one programming language. Maybe you've started learning a second programming language. This course is going to be, I think, like at a very nice sweet spot for you guys because we're going to be doing a fair bit of live coding, as I'll talk about in a second. And so you'll be able to follow along with that pretty well, but I think it will also be interesting enough that you'll maybe come across concepts that you haven't seen before. And then we have about 20% of registrants for this class who have a degree in computer science. Maybe you're a professional in tech, maybe both. And so if that is the category that you're in, I think you're still going to get a fair bit out of this course, maybe not in terms of like developing your programming abilities, but adding this visualization ability to your toolkit. And maybe the focus for you, if you're in this category, is a little bit less on the code itself and maybe a little bit more on, applying your coding knowledge to create visualizations in a particular area that is of interest to you. So if you're really interested in physics, maybe you can use this as an opportunity to learn how to create the basics of like a physics engine. Or if you're interested in like biology and computational biology, you can probably create some pretty cool, interesting visual simulations with this course. So I also bring up who this course is for another reason. Because of the wide variety of everyone in this course, I'm going to ask that if you're part of these former 2 camps, if you're part of that blue and red camp, when we talk about code in this course, if we write something that you haven't seen before, I'll do my best to explain it, but there might be some stuff that you might just have to Google as we're going through the course. This is not going to be a course that is how to program. You will certainly be able to pick up programming through this course, but the focus is not going to be on like, how do I write a for loop? Or how does the syntax work? It's going to be more broad in terms of like, what are the like paradigms that I can use to create visualizations using code. So you may have to do a little bit of Googling. I'll try and explain as much as I absolutely can. But then if you're part of this latter camp, if you're part of the yellow and green categories, you may have to sit through something that you've already heard before. Something might seem a little bit basic at the very beginning, but I ask that you, be patient with me in that regard, just because I want to make sure that the course is as inclusive as possible for everyone. All right, so let's start talking about what generative art is and, why might you be interested in taking this course in the first place. So we looked at maybe a broader definition for generative art in the pre-lecture readings that I had posted, and I think that's a really, really good definition. For our purposes, though, I'm going to change the definition of what we mean by generative art to be really, really broad, very, very encompassing. And it's really just going to be the use of code to develop any sort of creative audiovisual pieces. These might be animations, these might be static images, they might have some sort of musical component to them. But it's the use of code to develop these pieces. Now, I also want to point out that we may have deterministic and stochastic elements. And so what I mean by that is the deterministic elements, you as the artist, you as the generative artist, are going to choose exactly where things go, how they look, everything like that. You create the components and you determine exactly where they will be and how they will operate. But stochastic elements, elements of randomness, are also going to play a really, really important role in our toolkit, just because they open up so many possibilities to have a lot of fun with generative art. And as we'll see later today, randomness is going to play a really big role in just creating basic pieces that help you get a grasp of, what generative art is. And finally, generative art is something that can be interactive, not just for the person creating the generative art, but also more broadly for the people using the art. So the reason that I bring this up is because we're not going to mess with interactivity too much in this course, but I think that it plays an important role in generative art more broadly, and so I want to make sure that you guys are familiar with maybe some of the basics by the time that you leave this course. Okay, so why visualize nature? This is a course that's maybe a little bit interesting to you because this isn't just a course on generative art. It's also a course on natural and mathematical visualization, right? And that is going to be something that's different from a lot of other courses that you might see in this same vein. So why include this as a part of the course? Why visualize nature at all? Well, the first reason is I think nature is really pretty. I think it's a good thing to visualize because it creates all sorts of intricate, cool, interesting visualizations. And I think that in and of itself is a good enough reason. If you're looking for something a little bit more pragmatic, I think it helps us get a better understanding of our world. If we understand why nature works the way it does, then we can visualize it, and that helps us understand the world around us a little bit better. It also makes things like engaging with math, physics, and nature a lot more fun. Maybe you're somebody that isn't naturally attracted to these subjects, and that is totally fine. I was not a huge math person before I started my exploration into generative art, and I think that's made the process a lot more fun. And finally, the last reason that I think visualizing nature is going to be something that is important to do is it evokes lots and lots of interesting questions. It evokes a lot of what-if questions, and that's something that we're going to explore very, very thoroughly throughout this course. What if this thing in nature operated slightly differently? What if something was, a little bit different in its color or its shape or the way that it functions? How would that be different in the real world? How can we visualize those differences? And the final question that I want to talk about is if you've watched the TED Talk, and this was one of the pre-lecture videos as well, if you've watched my TED Talk, one thing that I talk about pretty in depth there is this question, is math invented or discovered? And I think generative art is a good way at accessing that question and really pondering, if I can create something that mimics nature in this way, if I can create something that mimics something like bird flocking or fish schooling, using just a few lines of code, what does that tell me about whether math is invented or discovered? And we'll sort of come back to this question at the very end of this course. But I think that it is something that might be useful to just keep in the back of your mind as we continue. All right, So how does this course work? It's going to be pretty straightforward. The first thing that we're going to start with is some sort of puzzle. There's some sort of interesting natural phenomena that we'll explore. And once we've learned a little bit about it, in class and lecture here, we'll create visualizations of it. And the hope is that you're able to follow along with the puzzle and the visualization in lecture, and that eventually will turn into art. And this is what a lot of the assignments of this course are going to be geared towards. Can you take something that we've built together and really expand on it, make it your own, make it creative? The other thing that I do want to mention about this course before I move on, the focus is very much going to be on live coding. So as I said before, I don't like speaking over slides. I think it gets kind of boring. And I really do want you guys to be able to leave this course with an understanding of how to code. And so to that end, what we're going to spend the vast majority of our time doing in future lectures and even sometime today doing is just getting our hands dirty with some code, writing code together. Throughout this process, I have absolutely no doubt I'm going to make a ton of mistakes. So hopefully you guys will be able to see just the process of creating and squashing bugs. And on that note, if you find any bugs that I write, don't hesitate to just call them out. The worst thing that happens is, maybe there isn't a bug where you thought there was, and that's a good learning experience for all of us. Okay, so quick timeline. Today we're talking a little bit about just the introduction to the course. We're motivating some of the course, and we'll spend a few minutes at the end of the course setting up our generative art environment and creating our first few pieces. Next lecture, which is going to be on the 10th, is going to cover some foundational concepts. We're really here going to be talking about how does animation work, how can we start animating, how do forces like attraction and repulsion work, and how can we use those to model some pretty basic physics. And then after that, we're off to the races. The next 3 lectures will all follow that sort of like puzzle visualization art format. And so on the 12th, we'll be talking a little bit about chaos and fractals. We'll be talking about how to create things like Sierpinski's triangle using nothing but chaos. We might talk about how to create stuff like snowflakes and other fractals that you might see in nature. Then on the 15th, we'll be talking about cellular automata. We'll kick it off with Conway's Game of Life, create a visualization for that. And then we'll talk about artificial life, stuff like Boyd's, to sort of get an understanding of flocking or schooling behavior. We'll also go ahead and try to code out some of that stuff. And then if we have time, we might even talk about like biological optimization techniques like ant colony optimization and how we can mess with that. Then on the 17th, we'll take a look at our final puzzle of this semester, which is going to be mazes and maze solvers. How do we create perfect mazes? Where do mazes exist in nature? And then how can we solve those mazes once we've created them? And then on the 19th, we'll go ahead and wrap things up. We will conclude by talking a little bit about visualizations outside of nature, how you can take what you've learned in this course and apply it to all sorts of patterns that might interest you a little bit more. Okay, so let's talk about tools. And I think this is also going to be like a pretty important discussion that we have right at the very beginning, because in a lot of ways, the tools that we use as generative artists will inform the art that we create. If we use a tool that is more geared towards primitives, then we might make animations that are more simulation-like. Whereas if we use something that is like a node-based tool to create art, that art might come out looking, very different. It might have qualities or elements that are quite different. So the first tool that I want to talk about is Touch Designer. This is a great tool. It's like a node-based generative art creation tool. So if you aren't comfortable with coding yet, or you don't really want to get your hands dirty with that sort of thing, and you're more at home in like a node-based environment, Touch Designer is a really, really great tool. Lots of awesome generative artists use it. And I can't recommend it enough, even though that's not what we'll be using in this course. If you're a big fan of Rust, or you're working with a lot of like analog physical components to create your art, then Nano is probably a good tool for you. Again, we won't be using it in this course just because one, I figure most people in this course haven't used Rust very much before, and it's a tough language to get started with if you're in one of the earlier camps that we talked about. So we won't be using Nano, but it is a tool that I think if you're a Rust fan, you will really, really like. Next, processing. This is actually the tool that we are going to be using throughout the entirety of this course, and so we'll talk about it a little bit more in depth soon. But processing is really nice. It's easy to get started with. There's tons and tons and tons of tutorials. So if we ever get to a point in this course where you feel a little bit lost, you're like, what's going on here? Rest assured there are tons of tutorials and resources for you to fall back on if you want just a little bit more clarity with anything that we're talking about. C4 is also a pretty good tool. This is another one that I haven't used, but I've heard good things about, and it's for iOS development. So if that's your jam, C4 might be for you. I also want to talk a little bit real quick about stuff like DALL-E and Deep Dream. These are really, really powerful and cool generative AI tools that are coming out, or have been out for a little bit and are widely used, but they're not going to be the focus of this course. In this course, the idea really is, let's get our hands dirty. Let's really understand how something works down to its very core. And we're going to want to create lots and lots of different types of things like animations. And DALL-E and Deep Dream are not going to give us the ability to tinker with things at the granularity that we'd like and really understand things at the depth that we'd like. So I want to mention them because they are still very important generative art tools, but maybe not what we're going to be focusing on for the sake of this course. All right, so let's talk about processing, because that's what we're going to spend the vast, vast majority of our time in this course using. Like I said, processing is incredible, tons and tons of resources. And the other reason that I think processing is cool is they have ports to tons and tons of different languages. So processing itself, like the base version, is what we'll be using, or I will be using, for demonstrations, but you guys are more than welcome to use any tool, any flavor of processing. So processing itself, you write Java to use it, which is pretty perfect. For me, I have a lot more experience with Java than I do most other languages, and so that's what we'll focus on here. But if you're more of a JavaScript fan, then P5.js is basically the exact same thing as processing, just ported over to JavaScript. There's a version for Android if that's what you're into. Version for Python, which I think a lot of people in this course will probably take advantage of. And there's even, I think, like an unofficial port to C++. I'm not sure if that's all the way done, but if you're interested in that, feel free to shoot me a message and let me know. Actually, on that note, we'll talk a little bit about communication for this class. Everything that we do will be over the Slack. And so if you're not already a part of that, let me know after this course ends. Okay, so another note, we have people in person here physically on Zoom right now that I'm live streaming to, and hopefully everything is getting recorded perfectly up there. And so you could be watching this course asynchronously, maybe during the actual time that it's running, or maybe you're watching this on YouTube. If you are, I'm really, really excited that it finally made it to YouTube. But all of the course materials will be on the course GitHub, which I'll show you guys in a couple minutes. And the idea is that they will be available and free forever. There's never going to be any sort of paywall for course materials. Okay, I think that mostly wraps up what I wanted to talk about. The one other thing that I do want to mention is other artists to follow. So I think throughout this course, just by virtue of me teaching it, I'm going to be showing you guys visualizations in the style that I prefer to create them, but I don't want to put pressure on you guys to create using my style. There are tons and tons of really cool generative artists that use processing, and they have completely different styles than my own. And so I want to spend a couple minutes before we get into the last bit of this lecture looking at a couple of different artists that you might like to follow, just so that you get an idea of what you can do. And throughout this course, if you prefer to create things in a different style than my own, prefer to create things in your very own style or replicate one of the styles of these artists, that would make me really happy. I have no illusion that my way of doing things is the best way or the only way. And And so I did want to show you guys that there are tons of different other styles before we start coding. How are we doing on time? Okay, not too bad. Okay, so the first one that I want to show you guys, the first artist, is Atten. I think that's how it's pronounced. I don't want to mess it up. But I think Atten's work is really, really cool because it focuses on a lot of these like perfect loop animations. And this is totally something that you can do with processing. I forget if Atten uses processing, but I think these are absolutely sick animations. I love, love, love a lot of them. And just the process of making them perfect loops is, I think, also really cool. So we can take a look at some of these. And what you'll probably also see is that a lot of them are composed of quite simple things. I mean, just dots, lines, basic shapes. But a lot of them use some pretty interesting geometry to make the loops super, super cool to look at. This one's one of my favorites. So that's one style. Oh, and all of the lecture slides, all links will be posted on the course GitHub and in the Slack. So if you guys ever want to take a look at any of these artists' pages after the fact, you are always welcome to do that. Another one that I want to show you guys is Andreas. So I've been following Andreas since I think almost the beginning of my generative art journey a couple of years ago. And I really, really like his work. So this is a website. I think it's a really sick website. But as you can see, Andreas focuses a lot on like ASCII and animations in that regard. I don't think he uses processing. I could be wrong. He might have used processing for a few things in the past. But regardless, everything that you see here can totally be done using processing. So here, maybe we can take a look at one of these patterns. And I think these are super, super cool. I've absolutely tried to replicate this style before, and I think if this is something that you guys are interested in, processing can totally do this. And it'd be awesome to see any of the work that you guys submit if it looks anything like this. I also want to show you guys the dot is black. This is another artist that I've been following for quite a while now, since really the beginning of my journey with processing. The dot is black uses processing for, I think, literally everything that they do. And what you'll see here is that, you know, their style is really, really different from that of Andreas or Atten, because a lot of their work is generally static. It has a lot of that simple geometry, and it mimics, you know, my interests a little bit closer as well. And so, in addition to everything that you see on screen here, they also have a great Instagram page. Most of these artists have awesome, awesome Instagram pages. But the dot is black also has really nice YouTube videos where they, you know, post a little bit of their work, live coding, stuff like that. So if you're looking for a place to get some inspiration, the dot is black is great. And I'm a big fan of their work. And the very last artist that I want to introduce you guys to is this artist called Pattern Seeing. And the reason that I think pattern seeing is interesting is because they expose this very different approach to generative art, which is a little bit more like simulation or data science focused. And so this is something that I wanted to show you guys. This is like a visualization of an epidemic like COVID-19. Again, I think created in processing. If not, this would be totally doable in processing. I've messed with ideas similar to this. And you can see that, I mean, really, there's some really, really cool stuff happening here in terms of people that are infected, healthy, and simulating that idea. And so this is just something else that you can do with the tools that you learn from this course. Okay, I think that is, yeah, that's everything that I had in terms of slides. So what I want to do now for the next couple of minutes, and this will really take us through the end of our course today, is take a look at processing and get our hands dirty with our first couple of visualizations. Okay, so another thing, I know that we have an hour and a half booked off for lectures. We are going to try and hit just an hour instead of like an hour and a half with each lecture. I'm going to try and be as respectful as I can of your guys' time. I know that we're in January. The sun gets down in the sky, it gets dark pretty early, especially here in Boston. So if we don't need the full hour and a half, we won't take it. I suspect that today we probably won't need the full hour and a half, but we might in the future. Okay, so how do you install processing? That's the first thing that we'll talk about real quick. You can just say processing download. You go to download processing, and you can go ahead and download it for whatever version operating system that you want. If you're on Mac OS, the only one thing that I would recommend is make sure that if you have an M1 or an M2, you download the Apple Silicon version. That version plays a lot nicer with the M1, M2, and I guess now M3 Macs. And if you have like a regular Intel processor, you can go ahead and download this version. If you want to use Homebrew instead, I think you can just go ahead and do brew install cask processing. I think I already have processing, so I'm not going to go ahead and do that. But if you prefer to use Homebrew for that, you're more than welcome to do that. Okay, so once you've installed processing, you're going to go ahead and have an environment that looks a little something like this. So we'll talk real quick about the IDE, and then we'll get into some of our first sketches. So the IDE that we have here is super simple to use. You just go ahead and type any code that you want in this main bit. If you want to run your code, you can go ahead and press run here. If you need to stop your code, you need to abort it for any reason, you can go ahead and press this stop button here. And if you want to make new classes, you can go ahead and do that by creating a new tab. So I think by default, especially like on Mac, the way that this works is every time you create a new processing sketch and you save it, it'll be saved in its own folder inside of your documents folder, inside of like a processing folder. You can obviously change the details of all of that. But if you're using this right out of the box, that's sort of how it works if you ever need to find your old code or sketches or anything like that. So the two most important functions when it comes to processing are setup and draw. Okay, so before we start actually coding, if this is your first time coding, or this is one of your first times really messing with Java, don't worry about syntax very much. The focus of this course really is not going to be how can I write this exact line, how can I, make this sketch the exact same way. As long as you get the gist of what's going on, it'll be really easy to fill in the gaps after lecture, especially if you're messing with some of this code by yourself. So if we create a constructor and you're like, what is a constructor? We'll talk about very briefly what that is at a high level, but in terms of the actual syntax, I'll leave you guys to mess with that on your own time. Okay, so the two most important functions when it comes to processing are setup and draw. And so the way that we can create our very first sketch ever is by creating the setup function and creating our draw function. And so the setup function is going to be run exactly once before our sketch starts like officially running. And so anything that you need in terms of setting stuff up, creating the size of the sketch, the background color for the very first time, you're going to want to do in setup. And then the way that draw works is it's just an infinite loop. It just runs over and over. And so every single frame, we will recall the draw loop, and you'll see exactly what happens with that in just a second. Okay, so here, let me move this back a little bit, make sure that focus is fine. Okay. All right, so let's create our very first sketch. We'll start by defining a size for the canvas of our sketch. We can do this in a couple of different ways. The first way is to create size, like call this function size, and you can define the size of the canvas. So this is a 500 by 500 canvas, and if we just press run, you'll see that we have a 500 pixel by 500 pixel canvas come up on our screen. Not very interesting. We're not doing anything at the moment with that. We can also full screen our application just by typing full screen there, and you'll see we have our canvas up in full screen. Okay, so I'll go ahead and leave this as full screen. And recall that the way the draw function works, right, it's just going to take anything inside of that function and keep drawing it to our screen. So maybe we start just by drawing a circle. So the way that the circle function works in processing is it takes 3 parameters. The first is the x position of the center. The second is the y position of the center. And the third argument is going to be the radius of our circle, right? So how big we want it. And here, let's go ahead and take a look at our whiteboard real quick, or blackboard here, and we'll sort of talk about how everything works in processing and with a canvas. So, you guys see that okay? Let me move this, maybe zoom in just a little bit. Okay, cool. So this is going to be our canvas here. Say it has some sort of width, W, and some sort of height, H. The way that our canvas works, the way that our coordinate system works in processing, is that our top left corner up here, that's going to be 0, 0. And our bottom right corner here, that is going to be our width, height. And so we'll talk a little bit more about why this coordinate system can get confusing, how it works, why it works the way it does, and how we can manipulate it in some of our future lectures, especially when we talk about how to mess with things in 3D. For now, though, just sort of take this as granted that the top left is always going to be 0, 0. The bottom right is always going to be our width, our height. And another thing that we'll want to mention real quick with processing is once we create the size, once we have something like full screen typed out on our sketch, 2 variables are initialized, width and height. And width is just the actual width of the canvas, and height is the actual height of the canvas. And so we can use these in useful ways. So let's go back to our circle real quick. Let's say we want to draw a circle right in the middle of our canvas, right? We want our circle to just be right there. What coordinate should the center of our circle be if we want it to be at the center of our canvas? Well, knowing that we start with 0 here and our width is right here, if we want this centered along the x, then we want this value right here, which is going to be our width divided by 2. And then very similarly, right, if we want this centered along the height, and if this is 0 height and this is our like maximum height, then if we want to center that, that'll be at our height divided by 2. And so we want the center of our circle to be width divided by 2, height divided by 2, and then we want to give it some radius r. We don't know exactly what we'll set as r yet, but we can mess with different values. So going back to our code, we said that we want to create a circle. If we want this to be in the center, then we need it to be our width divided by 2. And again, that width is that like keyword variable that we talked about just a second ago. We want the y position to be our height divided by 2, and we'll give this a radius of, say, 20. So if we go ahead and run our sketch, you will see indeed we do have this nice little circle, and it does look centered. Okay, let's make this circle just a little bit bigger. Maybe we'll make it of size radius 100. Yeah, okay. So we definitely have a little bit of what we're looking for here, but this isn't very interesting at the moment. And so, like I said earlier, we'll play with a little bit of randomness, and we'll hopefully turn this boring old circle into something that is somewhat interesting, somewhat resembles a piece of art. Okay, so the way that we will do this is, let's see, what parameters can we mess with? The first thing we can probably mess with is where this circle is on our screen, right? Maybe we don't want it in the center. Maybe we want it just thrown randomly around our canvas. We can totally do that. And maybe the way that we can do that is using our random function. So our random function is going to give us a value. It's going to give us a floating point value. So for those of you guys that aren't familiar with the difference between floats and integers, when it comes to programming. An integer is exactly what it sounds like. It's just a whole number. It is an integer. A float or a floating point value is a value that can have a decimal point within it. And so we'll go ahead and place our circle randomly anywhere between 0 and our width. And the way that the random function works is it's going to give us a random value between 0 and whatever parameter that we pass into it, exclusive on the parameter itself. So this will give us a random floating point value between 0 and the width of our canvas. And if we keep our height function the same, right, maybe we can think about what this does. If we go back over to our blackboard here, if our height stays here, but our width is random, then maybe we'll have a circle here, maybe we'll have a circle here, maybe we'll have one here. They'll always stay along this axis though, right? And so let's see if that is indeed what we get. And yep, that's exactly what we get. Cool, let's mess with randomness a little bit more. Just like we made our X position random, let's go ahead and also make our Y position random. And just for fun, let's also go ahead and make our radius random. And so I think what we should see here is just a bunch of circles that pop up all over our canvas in all sorts of different, all sorts of different places with all sorts of different sizes. Okay, cool. Yeah, so it looks like this is working. And I think maybe we can even venture to call this art now, very possibly. But also maybe not. We'll mess with a little bit more, see if we can get a little bit more artistic with what we've created. So, let's see. Maybe the next thing that we can mess with is color, right? Color is an important part of visuals. And so maybe we can mess with the color of the background, the color of the circles, the color of their outlines, mess with all sorts of different things here. This will give us a good insight into how processing works with color. So there are two different functions that you might want to think about when you work with color and processing. The first is stroke, and the second is fill. So the difference between stroke and fill is pretty straightforward. Stroke is going to be used to draw lines or outlines around shapes, and fill is going to be used to actually fill a shape. And so we can take a look at what that difference looks like here. Okay, so stroke and fill, like circle, also take in 3 parameters. By default, these are going to be your RGB values. So the first parameter is going to be the amount of red, the second is going to be the amount of green, and the last one is going to be the amount of blue that composes your color. And these values are going to range from 0 to through 255. I think that's inclusive on the 255 end. You might want to take a look at that for yourself. But the stroke, let's make this red. And so that's just going to be 255. That's as red as we can make it on the red channel. Remember, it's RGB. So on the G green channel, we'll just make that 0 and 0 on the blue channel. So we should get outlines of red. But maybe we want the actual fill color to be blue. And so the way that we can do that is we want to say we want 0 red, we want 0 green, but we want all of the blue that we can get. So if we go ahead and run that, what you'll see is indeed these have circles that are blue with red outlines. Again, maybe something that is interesting, maybe something that can be called art, but by my eye, it still looks kind of boring. So you can mess with this a little bit more now. Maybe we take the same randomness that we were using earlier for the circles and also make colors random. So let's go ahead and do that. Maybe we forget about stroke for a little bit. Maybe we focus just on our fill. And so we want a random color for all of our red, green, and blue channels. And remember, these go from 0 to 255. So we'll generate a random number between 0 and 255 for all of our channels. Little bit of a seizure warning here before we press run. Hopefully it won't be too bad, but this does get to be a little bit trippy. Okay, yeah, this is not too bad at all. Okay, now this is something that's a little bit more interesting. I think if you took just a circle in the middle of the screen and asked people whether or not that is art, I think you would probably get very few people that say yes. And if you show them something like this, I think you might get a lot more people that say yes, this is art. Okay, so this is somewhat interesting. Let's see if we can keep going with this concept, maybe for another like 5 or 10 minutes, and then we'll really explore our first like cool visualization, and then we'll wrap up and call it a day. So the one thing that I want to show you guys with color is that we're initially in RGB mode, and so these values refer to RGB values, but we can change that. We can change our color mode to something like HSB, and that's for hue, saturation, and brightness. Again, I think those values are between 0 and 255. And so the first channel will be the hue of the color. The second will be the saturation. Maybe we always want super saturated colors. And the third will be the brightness. So maybe we always want super bright colors. And so this is also going to give us a bunch of random colors. And you can see all of these colors are pretty bright and pretty saturated, which is exactly what we expect to be the case. Okay, I want to show you guys one last function before we get to our sort of like main event for the lecture in terms of coding. And that's going to be the map function. So our map function is going to do, I think it's just a linear interpolation between two different values. So if we have one value that is between a certain numerical range and we want to map it to a different numerical range, then we can do that using the map function. So what if we want our value, our color, not to be random anymore, but we want to map it based on where it is on our canvas? So if we go back over to our canvas here, if we take another look at what is happening, maybe the idea, right? The idea is that we can get rid of these circles. Maybe the idea is that we have random circles throughout our entire canvas, but the color right here is very different from the color right here. And if we can map these colors to their position on the canvas, then maybe what we have, right, is this really nice gradient over our entire canvas. I think that would definitely be worthy of a very basic introductory art piece. So let's go ahead and try and do that. So what we want to do is we want to map our hue from 0 to 255 based on maybe our position along the x-axis. So maybe we say anything that is, close to the left has a different color that gradually fades into a different color on the right. So maybe the way that we want to do this is we want to say that, we want to keep track of where we're drawing this circle, right? And so maybe we say that floating point x value is equal to a random value, and y is also equal to a random value. This should be height, not width. So this is a small thing that I overlooked on my part. We don't just want circles to be randomly distributed according to the width. On the height, on the y-axis, we want them to be anywhere along the entire height. Now, this didn't really make a difference for us because our width was bigger than our height, and so it looked like we were covering over like all parts of our height anyway, but we really do want this to be randomly distributed along the height. Okay, so we have those two float values, and so here, instead of generating these values randomly here, we can go ahead and use those randomly generated values. And we can go ahead and set our fill color to map this. Again, this is hue, saturation, brightness. So before we do this, we'll want to say we always want to be as saturated as possible. We always want to be as bright as possible. And our hue should be mapped. We want to take our x value and we want to map it from remember this can go anywhere between 0 and our width, we want to map that to a value between 0 and 255, because that's all that we can use for our fill value. And so what we should see here is, everything on the left, right, is going to be red. Then we're gradually fading into orange, yellow, green, light blue, dark blue, purple, pink, and then red again on the right side. Okay, I think this is pretty cool. Let's mess with this for just like 2 or 3 more minutes, and then we'll call it a day. So, or we'll call it a day with this visualization. We have another pretty interesting one coming up in a sec. Okay, so the last thing that we will mess with is mapping this maybe along the Y, and you'll see that we change where we are to be vertical if we do that. And we can even do something radial, right? And you might think about this on your own, but the idea here is super simple. Let me go ahead and stop this animation, go back to the board. The idea, right, if we want to be a little bit more radial with the way that we do this, is our color should be a function of the distance from the center. And so maybe we can take our X and Y coordinates, we can use distance formula to find the distance to the center, and then map that distance between 0 and 255. And so maybe you guys can do this on your own time if you have a couple of extra minutes. The concept shouldn't be too difficult, especially when you have some of this code to begin with. And what you'll see is that circles have a different color based on their distance as a function of where they are. All right, awesome. So here's what I want to wrap up with. I think this is going to be a very fun piece to get started with. We're going to be looking at random walks. And so the idea here is super simple. This will be a nice little introduction to object-oriented programming as well. The idea here is going to be that we want to create a sort of like little being that walks along our canvas in some sort of random direction. It's just out taking a stroll, and we want to visualize what that pattern looks like. And so the idea here is going to be, I think the big question that we always want to be asking ourselves with generative art like this is, in order to create it, what objects do we need? What attributes do they need to have? And what functions do they need to fulfill? And so here, if we're thinking about some sort of little person taking a stroll, maybe we can represent him using this dot. And maybe this person can go in one of 4 directions. He can go north, east, south, or west. And so maybe, he has the ability to move randomly along our canvas here. And we can go ahead and visualize that path, and maybe it's somewhat interesting. So, what are the objects that we need? Well, the object that we need is some sort of walker, some sort of thing that can walk. The attributes that it needs to have are probably a position, an X and Y position on our canvas. And the functions that it needs to be able to do are 1, show itself, right? Like show where it is. And the second one is obviously move in some sort of random direction every single time step, maybe every minute, every second, every hour, whatever the speed of this walker object is. So how do we do this? Let's go ahead and delete everything that we have here right now. Maybe we can keep that we want this to be full screen. And let's go ahead and in processing, if you want to create a new class, if you're using the IDE, you can just go ahead and press new tab. And so we want to call this a walker. Okay, so we want to create this walker object. In order to do that, we need a class for our walker. Again, if the Java minutia is not making a ton of sense, don't worry about it. As long as you have the concept down, we are all good. Okay, so we have our class walker. Remember, the most important attribute that we said it needed to have was a position. And a position on our canvas is really just represented using an X and a Y position. Maybe these will be integers. So we'll create an int X and an int Y for our walker. We want our walker to be able to display itself. So we'll create a display function. And we also want our walker to be able to move. So we'll also go ahead and create a move function. Okay. And the last thing, again, Java minutia, is we need a constructor to be able to create this walker. I mean, the idea behind the constructor is really, it gives us the ability to create an object. And so maybe whenever we want to create a new walker object, we need to initialize it with a initial position, like a starting position. And so maybe we have that passed in. That'll be our start x position and our start y position. And so to create our walker object, we need to set its initial start position to our x value and its initial y position to our y value. Okay, so how do we want to display this walker? How do we want to show it on screen? Well, we showed it here as this little dot, and this little dot moves around. So maybe we can start just by displaying a dot on our canvas where our walker is. And so we could use circle for this, but I also want to introduce you guys to the function point. The function point takes in only two parameters, just an x and a y position, and you can think of it just as a circle with radius 1. That's basically what it is. And so every time we display our walker, it will just put a point on our canvas at the walker's x and y position. Now, how do we want our random walker to move? Well, like we said, at every time step, we want it to randomly pick a direction and walk one unit in that direction. So the first thing that we need is a way to randomly generate which direction it'll go into. And the way that we can do this is we know that there are 4 directions that we want our walker to move: north, east, south, and west. So maybe we can just generate a random number between 0 and 3. 0, 1, 2, 3 is 4 different numbers. And depending on which number we generate, we move in a different direction. For example, if we generate the number 0, we move to the right. Or if we generate the number 1, we move to the left. So on and so forth. So let's start by doing that. So what we'll want to do is, this is going to be an integer, right? We want an integer value to represent the next direction that we go into. It's very clear when we have 0 north, 1 south, 2 east, 3 west. It would get really confusing if we had a number like 2.7 or like 4.3 or something like that. Because what does that 0.7 mean? What does that 0.3 mean? We don't want those, and so we'll stick with integers here. And so we'll say the int next direction is going to be a random number between 0 and 4. Now remember, the random function gives us floating point numbers, so we want to convert this to an integer just by casting it to an integer here. This will force it to become an integer. And then we want to say, hey, if our next direction is 0, then maybe we can go left. Otherwise, if our next direction is 1, then maybe we can go right. Otherwise, if our next direction is 2, then maybe we can go up. And finally, if our next direction is 3, then maybe we can just go down. Okay, so how do we actually go left, go right, go up, and go down? Well, this involves us changing our position, changing our x and y values, right? And so the way that we can do this is, if we want to go left, we take our x value and we want to move to the left. So we decrease it, maybe just by a step size of 1. And if we want to go to the right, we increase our x value by 1. Similarly, if we want to go up, we increase our y value by 1. If we want to go down, we decrease our y value by 1. Think of just this as like a coordinate plane with x and y values, and I think the process becomes a lot simpler. And that's it. We have given our walker the ability to move, and we have given it the ability to display itself. So let's go ahead and actually use our walker now. And so we can go ahead and create a new walker object. Maybe we'll just call this walker W. And in our setup, we'll go ahead and initialize this. We'll say this is actually a new walker that exists. We need to give it an initial position. Maybe we can start it out at the very center of the screen, which we said was width divided by 2, height divided by 2. And then this is I think where things will get a little bit interesting. What we want to do, right? What we want to do is have our walker at every single frame move and then display itself. So if we have a completely blank canvas, we want to start by showing where the walker is, moving, showing, moving, showing, moving, so on and so forth. And so in our draw loop, we just want to say w.move and then w.display. See if that runs. Okay, it looks like I made a mistake somewhere. Let's see, where did I go wrong? Oh, I don't have a end curly brace here. There we go. All right, I'm not sure if you guys can see that super easily online, but we do indeed have a walker. It's pretty small there in the center of the screen, but it's definitely moving. And that looks pretty perfect to me. Okay, so we've created our first random walker. This is really exciting. It doesn't look like much. It certainly doesn't look like art to me, but we do have a random walker that is walking. And we can do a lot of stuff with this very, very quickly. And so we'll go ahead and wrap up in the next maybe like 15 minutes or so. Try and get you guys out of here by then. The first thing that we can do with this random walker, and I think this is really like, it speaks to the essence of a lot of generative art. The cool thing about generative art is that it's scalable, right? If you were to go ahead and draw this generative walker on a piece of paper, no problem, take you a couple of seconds, pretty easy. But if you wanted to draw 10 walkers or 100 walkers or 1,000,000 walkers, conceivably that would take you 10 or 100 or 1,000,000 times the amount of time that it took you to draw one walker. At some point you're going to have to get up and eat or sleep or go to the bathroom, right? But the cool thing about generative art is that we can take one walker object and we can make 1,000,000 of them super easily. It doesn't affect us. The scale doesn't affect us quite as much as if we were working with pen and paper or any other type of medium. And so let's go ahead and create maybe like 1,000,000 of these walkers. Maybe not 1,000,000. Maybe we'll create like 20. But you could create 1,000,000 is the idea and the point. And so the way that we'll do this is instead of having just one walker, let's create a list of walkers. Let's create a list of walkers. We'll call them walkers. And so instead of just creating one, I'm going to go ahead and copy that. We can go ahead and use a for loop and say for I between 0 and maybe, I don't know, 50 walkers, we'll go ahead and create a new walker and add that to our list of walkers. So we want to add between 0 and 50 times a new walker. And instead of starting these all out in the exact same position, maybe we start them out randomly throughout the screen. What are we missing here? Oh, okay. So we initialized our walker with integers. And remember, random gives us floating point values. So we'll just go ahead and cast these to integers like we did before. And we should be all good now. Okay, now we want to say, we can't just say walkers.display and walkers.move. These are a list of walkers. And so we want to say for every single walker within our list, we want it to have the ability to walk. And so we'll say for every single walker W in our list of walkers, go ahead and move and then display yourself. So let's see what happens here. Oop, that's not good. Okay, actually this is a good learning moment. If you ever just have blank screen and then rainbow circle of death, that means you probably haven't initialized something. You have a null pointer somewhere. You have an index out of bounds somewhere. You have some sort of like runtime error. And if that is the case, you just want to go back to your original processing sketch. Go ahead and press that stop button, and it should tell you what the problem is. And okay, so the problem here is, again, sort of Java minutia. before I add stuff to my list, it's totally all right. We will forge on, and hopefully this will not be a problem for the recording. Okay, so where were we? We want to create, again, this is Java minutia, the problem with the null pointer exception. We're adding walkers to our list of walkers without saying that walkers is a list. If this is your first time messing with this stuff, that sounds really confusing to you. It absolutely is. The idea really is just that we've created this list of walkers, but we need to initialize it. We need to be like, hey, computer, this is actually a list of walkers. And if we try and add stuff to that list before the computer knows it's a list, it's going to get mad at us. So let me see. I'm not sure if we're back to cameras as well. Apologies again if that messed anything up. Okay, so we will continue onwards. I think that should have fixed that issue. So if we go ahead and press this run button, okay, this is really, really cool. We have a bunch of walkers on our screen. They're doing all sorts of really, really cool stuff. And by that, I mean they are just walking around. All right, so what can we do with these walkers? We're going to wrap up relatively quickly here. There's lots and lots of stuff you can do with these walkers. We can change their position. We can make them avoid themselves. We can have them fight for territory. And actually, that's going to be the first problem on the assignment, is just to create an interesting walker that does something cool. But I'm going to show you one cool thing that we can do with them, and then we'll go ahead and call it a day since this lecture is already getting a little bit long. So when I first got here, I got to Boston this morning, and when I first got here, I saw snow for the first time in Boston, which was an awesome, awesome experience. I'm from Georgia, so we don't see a ton of snow in general, so it was nice to see all of this pretty white snow piled up. But part of the pre-lecture videos, like I said, the very first one was my TED Talk. And in it, I'm drawing like a bunch of connections to fractals, and I remember I wrote the line, or I drew a comparison of some fractal to snowflakes in Boston, which is really funny because at the time I had never been to Boston, right? This was just, I was like, why not Boston? Seems like a fun place. And indeed, I was right. But it felt very full circle for me to come into Boston, to see snow for the very first time, and be teaching this course like later in the day. That was really awesome. But something that I did is take a picture of the John Harvard statue. And I thought it would be pretty cool if we mess with that picture, use it as input for these walkers. And so this is the part where I'm going to get just a little bit more advanced. So if this has been a complete snooze for you so far, maybe this is the time that it'll get a little bit interesting. If you've been following me so far and you've been finding this stuff maybe a little bit difficult, maybe this is where you lose me for the next couple of minutes, and that is totally okay. What we do here, you're not going to see us do in the course ever again. It's not going to be super important for the rest of the course. But I still think it will be a fun way to utilize these walkers. So what I want to do is I want to take our walkers and I want to use them to draw an image. Every time they walk over a pixel, I want them to draw a part of an image. So how do we want to do this? Well, the idea is going to be that we want to take an image, we want to put it on screen, and then we want to cover up the image so that you can't see any more of it. And then every time we have a walker walk over a pixel of that image, we want it to, in a way, remove that layer that we've put on top of the image so that what you see is really just the image itself. So how do we want to do that? Well, in processing, we can do this in a pretty interesting, pretty clever way. We can go ahead and take our image, put it up on our canvas here, and then we can load all of the contents of the image into the pixels array of our canvas. And so the way the pixels array works is pretty interesting. I mean, if you just think of our canvas, right, as this grid of pixels, which really is just what it is. It's just a big grid full of pixels. When we display our image, there's a bunch of data in these pixels. And we want to say to processing, okay, save all of this data. Take every single bit of the image data that we have right now and save it into like this grid format. And then we'll cover this image up. And then every time we walk over a place, if we walk over here, if our walker is right here, we want to say, hey, processing, remember that picture that we gave you earlier? We saved all of that data for? Give me whatever was in this cell. I want to show whatever is in this cell. And that will help us recreate the image. And so that is like how we'll use our random walkers for the next couple of minutes. Okay, so I should probably start by showing you guys this picture of John Harvard. So let me go ahead and open it up. Ooh, don't want all of that. Let me go ahead and open up this picture of John Harvard. So this will be in our code in here. Let's go ahead and open that up. Here's our picture. It's I had to scale it down just a little bit, but this is indeed John Harvard. It's all snowy. So I want to take this picture and I want to recreate it. And so the first thing that we'll take a look at is how do I do this in processing? Like how do I get this picture of John Harvard into processing to begin with? And so let me start by saving this sketch. So I'll go ahead and call this the lecture 1 walker. I'll save it inside of processing. And so now what I can do is I want to take this image that I have and I want to copy it over to the folder that I have for processing. And I'll go ahead and use my terminal to do this just because I don't want to show you guys everything that's in my Finder. So I want to copy this image to Documents. And inside Documents, there's a processing folder. And inside of that processing folder, there's a lecture 1 walker folder. So I'll go ahead and copy this into that. And now I want to go ahead and display this, this walker. And so first of all, I don't want to be full screen anymore. I probably want to be like 500 by 500 because that's, I think, the approximate size of the image. We don't want this huge canvas and the super tiny image. So we'll go ahead and decrease our canvas size to be approximately our image size. And then we want to load this image, and so we will say p_image, and we'll just call this JH for John Harvard. P_image JH is equal to load image, and this is how we load an image from a particular file path into processing. And we just have this in our lecture 1 walker folder, which is exactly where this code is. So we can just say jh.jpg is where this picture of John Harvard is. And then if we want to go ahead and display that image, we can just go ahead and do that by saying we want to display the image JH starting at 0, 0, starting at that top left origin point. Go ahead and press that run button. And okay, we get our picture of John Harvard. And if you look closely, you'll see that we have a bunch of walkers walking over that picture of John Harvard, which is it's kind of rude. That's not what we want. But it's close, right? So this is doing the inverse of what we want. John Harvard is visible here, and we are walking over the picture, so you're no longer able to see John Harvard. What we want is the opposite. We don't want to see John Harvard to begin with, and then as we walk over the picture, we want that picture to become visible. So how do we do that? Well, what we want to do, right, is we want to take all of this data. We have all of this image data, and we want to save it into our pixels array. And so the way that we can do that is we can say load pixels. And the way that this works is it's going to take everything on screen right now, and it's going to load it up into a big long list called pixels, and each pixel color is going to be saved in that list. And then we want to say, all right, we have the picture of John Harvard here. We've loaded all of the data up. Now we want to obscure it. And so maybe we cover it in white in a sheet of snow. And the way that we can do that is by using this background function. And this function is going to work just like the stroke function or the fill function, where it's going to take in an RGB channel, unless we've changed that to HSB by changing the color mode. And in this case, we want white, which is going to be 255, 255, 255. But we can also shorthand that just by saying background 255. And so now if we look at what happens, what you'll see is that we've loaded this picture up, but then we've covered the picture up in the background white, and so it'll just be white background and black walkers on top, right? And again, they're still just drawing black. They're not drawing anything related to our picture. And so that's the last thing we want to change. We want each of these walkers to draw the pixel of the John Harvard image that we've loaded into our pixels list. So how do we do that? Well, we probably want to mess with the way that walkers display themselves, right? Right now, they're just displaying themselves as a point, and that point is defaulting to black. Instead, we want to change that stroke color. So a point has no fill. It only has a stroke. A circle has a stroke and a fill, just processing minutia. So how do we want to access the right color? Well, we've taken all of this data and we've loaded it into this super long list that internally is just called pixels. Hopefully you guys can see that. Let me move this over. Okay, there we go. So we've taken all of this data and we've loaded it into a big long list called pixels. Now, the unfortunate thing is that we think of things in terms of a grid, right? We have an X location and a Y location. We've taken all of that, and it is unfortunately now just one big long list. And so we've compressed it. The idea here is that we've taken this row and appended it to this row, appended it there, and so this grid has now turned into a list. And so we want to figure out what is the color at a particular XY position, but we can't put in an XY position because this only has X positions, right? And so if we have an XY position and we want to convert that to just an X position, we know that there are a bunch of these. There are width number of pixels in the width of our canvas, right? That's exactly what width means. It's the number of pixels we have in the width of our canvas. And so if we are one row down, then we want width plus the number left over to get us here, right? We want width, which covers this first row, plus the number that we have left over in our X value. And if we were down here, then we would want 2 times our width plus X. And in general, if we have some Y value, we want Y times our width plus the X value. Hopefully that idea makes sense. If it doesn't, that is totally okay. You might need to do the math by yourself to convince yourself that it works. But we're running low on time, so hopefully you guys will also just trust me and trust the code, because we'll see in a second that, again, fingers crossed, that this works. So we want our stroke position to be the same color as our pixel. So we go into our pixels array. Again, this is something that's created for us by processing when we call the function load pixels in our initial function over here. We want this pixel color to be Y times our width plus our X. And that's the equation that we just said a second ago. So when we press this run button, hopefully we should get, right? Yeah, this looks a little promising. Okay, there's a problem here. We're out of bounds. Okay, so this is actually really interesting. I hadn't thought of this, but now that I think about this, this is totally going to give us an error. And the reason that it's going to give us an error is because if we take another look at our canvas here, if we focus, if we take another look at our canvas here, what's going to happen is our walker, right, might walk off our canvas. And if it does that, then processing is going to say, all right, we want to display whatever is in this pixel. But this pixel doesn't exist in our pixels array. It exists outside of our pixels array, maybe somewhere off to the side here, and we can't find it. And so processing is going to be like, wait, hold on a second. And Java is going to be like, no, you can't access this, this pixel, so it's going to give us an error. Now, the way that we can fix this is there is a inbuilt function. So there are a couple of different ways we can fix it. We can have our walker walk off the screen to the left and then re-emerge on the right. If it walks up, then it re-emerges from the bottom, and that's totally a fine way to go. we can also use a function in processing called constrain. And so we'll take a look at that right now. Basically, we want to constrain our movement. So right now we're back in our constrain function. We want to constrain our x value to be between 0 and width minus 1. And we want to constrain our y value to again be between 0 and our height minus 1. Have I done something wrong here? Oh, yes, I have done something wrong. This needs to be inside of my move function. So down here. Okay, so now we're constraining our pixels. Let's go ahead and rerun this. And okay, yeah, if you look closely, I'm not sure how well this is translating, but if you look closely, it does look like we're doing a bunch of different colors. It's a little hard to tell if this is John Harvard right now. And so we'll actually speed this up. So the way that we can speed things up in processing is by messing with the frame rate. And so if we set our frame rate to 1,000, then we'll get some really, really fast walkers. Oh, looks like we're out of bounds again somewhere. I'm not sure where that is exactly. We'll rerun that. Okay, so we're definitely going out of bounds somewhere. It's not immediately obvious to me where, but let's take a look. So we're going out of bounds. And you know what I think it is? We might need to move after we display. Let's try that. I'm not sure that that will necessarily work. But let's go ahead and try that. It might also be that our image is not 500 by 500 pixels. If that's the case, that will definitely cause an issue. Okay, yeah, it looks like we're going off of one side. And so we're getting an index out of bounds error somewhere. All of this looks correct to me. It could be that this constrain function is not working the way that I intend for it to. That is also a distinct possibility. So it's not always liking our width. So it looks like our y value, right, might be out of bounds because it's giving us a negative value here. And so maybe what we'll do real quick is I'll pull up the code from the other recording of this lecture that I have. Let me go ahead and pull that up. Let's go ahead and print out our walker. What are we doing here? I think this, oh, okay, yeah, of course. This constrain function, I was messing up how this constrain function works. We need to constrain our x and y values by setting x equals the constrained value and y equals the constrained value, not just saying constrain. And there we go. Okay, that also did not work. And I know the reason that that didn't work. That's because it just needs to be width minus 1 and height minus 1. Ooh. Otherwise, we go out of bounds there. There we go. All right, I didn't want to speak too prematurely, but yes, okay, perfect. So looks like we are creating the picture of John Harvard here. And what's really, really cool about this is, of course, this will work with, any image. We can change it to any speed. We can stop this animation at any point and just have like this cool half-ish finished picture of John Harvard in the snow. Okay, awesome. So while we keep this thing running, In terms of next lectures, future lectures, next lecture we'll be talking a little bit more about some foundational concepts that go behind creating visualizations and processing. We'll be talking about things like forces and how they interact with processing. We'll maybe be creating our very first visualization of something in nature. So hopefully that is a fun experience. I really appreciate having you guys here. And it looks like our picture of John Harvard is now finished. Awesome. So few last administrative things before we close out for the day. If you guys need any help with anything, first assignment is posted. It is highly encouraged, but optional, so you don't have to do it if you don't want to. It is just 2 problems, and I have devoted the entirety of my next 2 weeks to this course. So if at any point you need help with anything, feel free to drop me a message on Slack any point in the day. Let me also show you guys how to go ahead and access the GitHub for this course. It is super straightforward. You just need to go to github.com/myfullname/code-the-universe. That is code-the-universe. And you should be able to see the syllabus, the assignments, the lectures, everything like that get posted and updated. And if there is any code that isn't posted here that you would like posted, go ahead and let me know, and I will make sure that it gets posted. Awesome. Well, remember, next lecture is going to be Wednesday, 4:30 p.m. here in Jefferson Lab 356, or on Zoom if you prefer to join that way. But yeah, thank you guys so much for coming, and I will see you in the next lecture.